For this problem, must find the position of an object after being hit after 1.5 seconds, and the hit does occur at the origin. Now your givens are your mass 1.8 kilograms and the velocity of 30 meters per second, and the velocity is in the x direction, the positive x direction. Therefore you can make it into a vector. It would be the vector velocity equals 30 in the x, and then 0 and 0 in the y and z, because it is only moving in the x direction. And that's meters per second. Now the momentum is mass times velocity. Since it's a vector, it's the vector of momentum equals the mass times the vector of velocity. So the vector of momentum is the mass 1.8 kilograms and the times the velocity 30 meters per second. Now whenever you have a scalar and multiply by a vector, you multiply this out like that. So you multiply it by every single coordinate, or like the x, y, and z. Whenever you get 1.8 times 30, you get 54. Of course, whenever you multiply 1.8 by 0, you get 0. And so that's going to be 54.00 kilograms meter per second, because mass is in kilograms and velocity is in meters per second. And that gives you your initial momentum. Now for the next part, you are given the F net and the change of time. Now the change of momentum is actually F net times the change of time. So the change of momentum would be 0 times 2.4 10 to the negative 4th, which is 0. 12 times 10 to the 5th times 2.4 times 10 to the negative 4th, which is 288, and 0 times 2.4 times 10 to the negative 4th, which is 0. Of course, that's kilograms times meters per second, because it is momentum. And then you are given over here your change in momentum. Well, now that you have your regular momentum, your initial momentum, and your change of momentum, you can solve for the second momentum, the ending final momentum. And the equation for that is that the change of momentum is equal to the final minus the initial. So because of that, you can organize this given equation over here to look for the final momentum. And the final momentum is the initial momentum plus the change in momentum. Now once you actually put the numbers in that you found, your initial momentum and your change in momentum, you will just basically combine them, because this one's in the x coordinate and this one's in the y coordinate. Therefore they don't affect each other, so they just go down. So it'd be 54, 288, 0, because it's 2 zeros and to 0, and you get, well, your final momentum as 54, 288, 0 kilograms times meter per second. Now at this point you're trying to find your velocity, so you can end up finding your final position, and your velocity is actually equal to your momentum divided by mass. So now, since you have your momentum and you have your mass now, or you were given your mass from the beginning and you just found your momentum, you can go ahead and plug in your momentum, 54, 288, 0 kilograms times meters per second, divided by 1.8 kilograms, which is your mass given in the beginning, and you will get 54 divided by 1.8, which is 30, 288 divided by 1.8, which is 160, and 0 divided by anything, of course, would just be 0 meters per second. Now that you have that, you can go ahead and look at the equation. The average velocity, which you just found basically, equals the change in position divided by the change in time. If you reorganize that, you can solve for the change in position, which is what you're trying to look for in this case, and you will get change in position equals the average velocity times the change in time. The average velocity is 30, 160, 0 meters per second, and the change in time is 1.5 seconds, because you're trying to look for the position after 1.5 seconds of being hit. And so once you multiply 1.5 seconds by 30, 1.5 seconds by 160, and 1.5 seconds by 0, you will get 45, 240, 0 meters. And that's going to be your final position, since it started at the origin, meaning that the change in position will end out exactly at where it is, where the final position is, because it started at 0. Thank you.